Hello, my name is and I'll be guiding you through an overview of an IT project called Inventory Systems. I will highlight its key components and explain how the final system operates. We'll use a constructed model prototype to visualize the working principle, and I will show you a web interface to demonstrate all the features. So, let's begin. The goal of the project was to build an employee time tracking system along with an electronic access control system in the workplace. But our imagination took us a little bit further. Anyway, let me start from the beginning. I will back with this feature later on. The project included 3 sections. 1. Building a CRUD backend application with a database. 2. Creating a web interface for HR personnel to add and remove employees, assign appropriate access permissions, and generate various reports. 3. Developing hardware based on the ESP32 microcontroller, programmed on the Arduino R4 board, with an RFID card reader. The hardware was built to read employees' cards ID and send requests to the application and then control the mechanisms for opening and closing gates. Let's take a look at web interface now. The user interface was designed for HR personnel, making it easy to add new employees and assign them appropriate permissions. The Report and Search tab allows for generating various reports, searching for employees by parameters, activating and deactivating cards for selected employees. It also allows generating logs for employees or a specific employee within a given time frame. We can also generate a list of employees currently logged into the system, or we can generate a list of employees filtered by their access hierarchy. All reports are downloaded in a universal XLS file format, allowing for further use. The entire entrance gate mechanism is controlled by an ESP32 microcontroller, programmed on the Arduino R4 board. The microcontroller's source code allows reading the employee's card ID through the RFID reader, then sends an HTTP request to the appropriate endpoint of the application via the Wi-Fi protocol. The request is sent with 2 parameters, card ID and gate ID. This request logs the appropriate entry in the application's database, changes the employee's status to the opposite, and the response information is returned back to the microcontroller. Let's take a closer look at our entrance gate model now. All components are controlled by the aforementioned ESP microcontroller. The RFID reader is responsible for reading employee cards. Just place the card on it. The LCD display shows current information. The gate barrier is controlled by a servo mechanism that raises it when the backend application validates the card ID and grants entry permission. The red and green LEDs indicate access status. Press the information button while placing the card to the reader to obtain the employee's current log status. The buzzer is an alarm that is triggered in case of an unrecognized card. Let's now take a look inside our model. Listing from the top, LCD display, RFID card reader, information button, green and red LEDs, servo motor, and buzzer. Let's perform few simulations now. Entry simulation, last login check simulation, exit simulation, and an attempt to enter using an unrecognized card. Let's pause now. Using an unrecognized card triggers the alarm. According to the project, this alarm should prompt a response from the security personnel. Unfortunately, human resources have some weaknesses. Therefore, we implemented an electronic security guard feature that reacts when someone attempts to access the gate with an invalid card. The robot was found in the children's playroom. It could move forward and backward and had independent drives for each wheel, so it could also turn. This was sufficient for our needs. The next step was to replace the original board with an Arduino Uno module and upload a movement algorithm to it. An appropriate piece of code was also implemented on the gate controller to establish the connection between the gate and the robot. This connection was achieved using an infrared beam interruption sensor. The transmitter was installed and connected to the gate module, and the receiver was attached to the robot. From now on, triggering the alarm initiates the robot to execute its code. Thanks for watching. If you're interested, you'll find a link to the GitHub repository with the application codes, gate codes, and robot codes in the description. Bye.